Good morning. So this video deals with the synthesis of cis trans diols. So cis trans diols are basically dihydroxy compounds, and we can synthesize either the trans or the cis depending on the reaction conditions. Our starting materials in this case are both alkenes. However, in the first reaction that you see here, we're starting from the classic cyclic unsymmetrical alkene, and we are reacting first with a very interesting reagent, which is a peroxy acid. Peroxy acids are written as RCO3H. It can just say peroxy acid, or you might see some kind of abbreviation of the full name of some of these compounds, which is MCPBA. All you need to know in this case is the peroxy acid generates a very interesting type of compound, which is a cyclic ether, which is called an epoxide. So this is an epoxide. Is basically we're forming a three-member ring with an oxygen at the top. So epoxides are cyclic ethers. We're going to encounter them in organic too, but in this case they're actually used to synthesize trans diols. So the first step is forming the epoxide. In the second step, we're actually using H plus and water. So the H plus is used to protonate the oxygen. So the oxygen will attack the hydrogen. The reason for this attack is to make sure that then the oxygen becomes a good leaving group. So oxygen is going to bond to the hydrogen, and it becomes positive. Now, this intermediate is very similar to intermediates we've seen in this chapter on alkenes when doing halogenations. We're doing oxymercuration, demercurations, halohydrin formations. So this is now susceptible to attack even from weak nucleophiles. And in this case, we have water present. So now the water is going to attack our protonated epoxide. Now, where is the water going to attack? Now, remember, always look at the three-member ring with the positive charge, and you'll notice that the carbon at the top, this carbon here, is actually more substituted. So the water is going to attack that carbon. Stereochemistry is going to change, and the bond between carbon-oxygen is going to break. So it's a backside attack. We need to indicate stereochemistry. So we're going to have an OH forming at the bottom carbon. Stereochemistry on the other side is going to change. CH3 is going to stay there, and the water is coming in from the opposite side. In the final step, we're going to use another molecule of water, and this will deprotonate the OH2+, making it neutral. So this will give us the final product, which basically is going to be a compound that where you add the double bond now has two hydroxy groups, which are trans to each other. So this compound is our major product. It's called a trans diol. Diol because there are two, that's the di. Ol because it's the suffix normally used for alcohols. So this is how you make trans diols. It's the only reaction that you're going to see in this chapter that allows us access to this kind of compounds. However, as you know, in organic chemistry, we always need the option to actually synthesize other type of compounds. So what if I want to make a cis diol? So for cis diols, there are two reagents that you can use, and that would be reaction number 2 that you see here at the bottom. And the reaction involves using one or two reagents. There is osmium tetroxide base combination. So osmium tetroxide is a fairly expensive type of reagent. So it's used either neat or is used in combination with other kind of reagents. Generally speaking, if you see osmium tetroxide or a diluted cold solution of potassium permanganate, the reaction will give you the cis diol. No mechanism required in this case. You can just provide the final product. The only thing to keep in mind, this is a syn addition, which means the two hydroxy groups get added on the same phase, which implies they're going to be either both wedges or both dashes. In both these cases, you always get the enantiomers, okay? So if you're forming chiral centers, you're going to get the enantiomer. And the same story happens for the cis diol. So whenever you are facing with questions that ask you, okay, how would you make diols? These are the only two set of reagents being used. Either you make an epoxide first, and then you open it up with water. That gives you the trans. If instead you are aiming to synthesize a cis diol, then you want to use pretty much just either osmium tetroxide or potassium permanganate. Thank you.